All right, I'm going to do a problem from each section of the Basics of Geometry 1 worksheet. Basically kind of explain how to do everything. So number 1 says that we're going to use a ruler to measure the length of each line segment, measure each segment in millimeters. I have rulers at school here. You're going to need to measure this on the paper if you want the correct answer. If you measure it on your screen, it'll be slightly different based on your screen size. So if you are measuring on the screen, it will not necessarily be the same answer. That doesn't mean you did it right or wrong, but the numbers I'm looking for is based off the 8 by 11 green paper that we have at the school. So if you need a hard copy, you'll probably need a hard copy for that one. We'll get that on Wednesday or Thursday, depending on what day you're here. So remember, the ruler is going to tell you centimeters. So that means each number is 1 centimeter. That means there's 10 little dot line, or there's little line dashes in between the numbers. Those are for millimeters. So this is, for number 1 is like almost 6.5 centimeters. It's actually 6, and then it's the 4th dash. That's what I saw. So I measured that in millimeters, and so I'm going to measure that on with a ruler, and I end up with 64 millimeters. Don't forget I'll make that a little more legible. So it's 64 millimeters, and you're going to need your label for that. So the segment addition, the segment addition postulate basically says if you have one piece, so I have this red piece which is 4, so I have a red piece. I don't want red piece which is 4. I have this green piece which is x minus 5. Together they give me the blue piece. Right? So basically this states that I can do 4, that's the red piece. I can add it to the green piece, and then it's going to equal the blue piece, 2x minus 13. Once we have this set up, it's just like a problem from the pink paper in our last quiz. So I'm going to do 4 minus 5, so I'm going to have x minus 1 equals 2x minus 13. Now it's just a solve problem, so I'm going to put all the x's on one side. I'm going to minus x from both sides. So I'm going to end up with negative 1 equals 2x minus 13. I don't know why I put 2x there. 2x minus x is just 1x. Now I'm going to add 13 to both sides. So I end up with x equals 12. Now I'm going to check my work here. So it's important to see if it makes sense. It is possible with geometry, sometimes you'll have the right algebra, but geometry is not possible due to however it worked out. Maybe it's just not realistic, because in geometry we're talking about distance, and distance always has to be positive. So I'm going to put 12 in right here. So this is going to be 4. The green piece should be 12 minus 5, which is 7. So I have the red piece is 4, the green piece, the whole green piece, should be 7. So 4 plus 7 is 11. So now I'm going to put the x into the blue piece. 2 times 12 is 24. 24 minus 13 is 11. So it does work out. That's how we're going to do 6, 7, and 8. So now, all right, I'm going to go over there's a problem for each section. So number 9, so 9, 10, 11, and 12 are all going to be similar. You probably need a protractor. If you don't have a protractor, let me know, and I'll get you one. So protractor. Use the protractor. Like, if you didn't have a protractor, I at least know right away that, like, I know that straight up and down would be 90. It's a little bit harder to draw this. So that green would be 90. So I know 100 is bigger than that. Now I'm gonna use my protractor. I'm gonna go to 100. Right. I made a little line there. Right, and then I'm gonna use that to connect. Now, so my blue line is gonna be my actual angle. So I'm going to connect it solidly. We'll see if I can do this. Right. Not the best at making these lines, but I'm trying. It's a little bit harder when I'm doing that. So the green dotted line would have been 90, like a right angle. Now remember, this is a ray, so it goes on forever. So it's called a ray. It's like a line segment that goes on forever. So the blue line should be 100 degrees. And that's really all that is. So it's just using a protractor, which you've probably done before in the past. And you use the little circle for degree symbol. All right. 13 classify each angle as acute. That means it's less than 90. So less than 90 degrees. Obtuse, greater than 90 degrees. But actually, it's going to be but it's less than 180. So right is exactly 90 degrees. And then straight is going to be exactly 180 degrees. That's like a straight line. So that's how you know which one to pick. Well, 90 would be, that would be 90, right? If that had a box in there, it doesn't. So it's less than that, which means it's going to be acute. So now, naming the angle in 4 ways is just different notation on how to write an angle. Notation becomes really important in geometry because we end up doing proofs. So you have to know how to write stuff. So there's going to be a bunch of different ways to do it. I'm going to use this angle symbol. And you can use 3 letters as long as this is in the middle. So that's your vertex. So I could say angle A, B, C. That's one option. The other thing I do is I could just, as long as this doesn't have a bunch of, like, as long as this is the only choice for B. So let's say if I had like a green line that goes right there, this would not be a good choice to say use this method, because if I said angle B, I could be talking about the left side or the right side. I would have to be able to differentiate between there. Now luckily this one's not saying it, so angle B is totally an option, right? The other way you could do it is you could, once again, use the 3 letters, but this time you could say CBA. So these are interchangeable. These are all just different ways to say the same thing. But as long as B's in the middle, it doesn't matter if you go ABC or CBA. As long as it's the only option is angle B. If the only vertex that B is touching is this angle, you can use that one. Or you could just use the number, right? There's a number right there. So angle 5. So notice I use this little, it's the angle symbol right here. So this is the angle symbol right here. Just like a little angle, all right? See, there's the angle symbol there. Now this, so 17, 18, 19, very similar, or 17 through 20, just very similar. 21 is like the angled postulate. Basically it says if I have this green piece and I have this red piece, the whole thing will equal the blue piece, right? They use this little m that means measure. So when you give me a number, usually you say the measure of angle. So this, when I read this, I say the measure of angle RBA. So the measure of angle RBA, so RBA, right? So R then goes to B. It's like connecting the dots. Then A. So that's this piece right here. RBA is the green piece because it goes from R to B to A. So they're saying RBA equals, oh, we need to find it. So we don't know RBA. I'm going to put a question mark there. A lot of times we'll use X. So it says find RBA. They don't tell us what RBA is. So we'll say X. Right? Or you can put just question mark if you want. Plus the red piece. So the red piece is CBR. So C then goes to B, then goes to R. Well, CBR is 29 degrees. Right? And it's going to equal the blue piece, which is CBA. Look, C goes to B, goes to A. That's how you know which angle you're talking about is connecting dots. So that equals 89. Now we just have a nice simple algebra problem. We've done that. So basically in one step we want to take our geometry, that's what we have in 21, and we want to make it look like simple algebra we've been doing. So I minus 29 from both sides. I get X equals 60 degrees. All right, so the last thing I'm going to do is I'm going to actually write my answer the correct way. So that means you actually say little m, angle symbol, RBA equals 60 degrees. Notation is going to become important in geometry, so I will be very picky about the notation. So don't lose a half point or something because you were too lazy to write the following notation. It didn't say to find X, it said find the measurement of RBA. I did that there. All right, that's it. All right, last thing I want to go over 2 more. So 25 through 28 will be kind of similar like this. You want to name different types of relationships. Oh, so a complementary relationship would be would be two angles that equal 90 degrees. In theory, it could be more than two, it could be three, right? Linear pair is a pair of angles next to each other, or two angles that make up a line. Vertical angles are across from each other. I don't like how that looks. Vertical angles are across from each other. Adjacent angles are next to each other. I could say next door a lot. Alternate interior angles. So this is, I'm going to use this this notation a little bit. We'll talk a lot about this coming up in class and stuff. I'll say two parallel lines cut by a transversal. And I'll shorten it and I'll say this. Alright, I'll say two parallel lines cut by a transversal. I might not use so you'll see if you ever see something written down that looks like this. That means I have two parallel lines cut by a transversal. You need that for alternate interior, you need that for corresponding, or you need that for alternate exterior. We'll go a lot more into detail. So like, if you don't have two parallel lines cut by a transversal, and a transversal would be like, I would say a bridge between two lines. So for here, this would be the two parallel lines, the blue, the green would be the transversal. So this would be the two parallel lines. Oop. The transversal is the green, the two parallel lines is the blue. So this would be a time when you use something like that. So there's no way that 25 can be any of alternate exterior, corresponding, or alternate interior because it doesn't have two parallel lines cut by a transversal. So okay, it has to be either complementary, linear pair, vertical, or adjacent. Vertical angles would kind of look like, so vertical angles you would probably need to have something that kind of looks like this. You would have two lines in vertical angles. So vertical angles would be like this guy right here across from this guy. They're vertical, right? These are vertical. All right, so we don't have that, so there's no way it's vertical in this one. So A and B together make up a line. A line is 180 degrees, so there's no way it's complementary. So it's going to be called a linear pair. You could also say adjacent, but in theory, a linear pair, it has to be adjacent by definition. They have to be two lines together next to each other that make up a line. So adjacent is an okay way to name the relationship. It's better to say linear pair. All right? So 29, we're going to have different things that these marks mean. So what we find out is marks like this, those means congruent angles. So I'm going to use this symbol right here. That means congruent, not equal to. And I'll explain that during class about the difference between equal and congruent. I spelled congruent wrong. That's totally wrong. Can't spell. Let's try and fix that. See if I can write this time. So congruent, this means congruent. That's spelled right. Right? And so we write that just like, now you could say angle X and angle Z. I want you to get in the habit of using three-letter notation. So I'm going to use three-letter notation. So this angle right here is going to be Y, then X, then Z. Remember, X is the vertex, so it's in the middle. So I say angle Y, X, Z, or I could say Z, X, Y, or I could say angle X is congruent to angle X, Z, Y, or yzx. So that's the first thing, right? Now I see these little triangles. That means parallel, right? So the little triangles mean parallel. So I'm going to say VW. Now I'm using V and W. VW could mean a whole bunch of things. So I have to put a little double arrow on top to prove that it's a line. And this little double bar means parallel. Now I'm going to say XZ. There's a bunch of different ways to see notation, but this is proving by putting the double arrow on top. It tells me it's a line. I see right there. So now I got two more angles congruent to each other. So I'm going to say angle WVU is congruent to angle WUV. See how they have different the vertex? This is the vertex. It's the middle of each one. All right. That's going to finish this. The one thing that I didn't show in this one, I wish I would have, but let's just say this isn't necessarily true. But if you saw lines like that, that also means congruent. That's when you would say segments are congruent to each other, not lines. So if it's something like that, then I would have VW segment, not line, is congruent to XZ. Now that's not true in this. Not true. I just made this up to show an example. That's definitely not true, unless it was there. So information given. Given is stuff already printed. They gave it to you. That's why this green stuff's not true, because I made up the green marks. It's not really there. All right? So that is it for Firestarter 14.